All right, so we're talking about roots of polynomials today. We've already spent quite a bit of time talking about the roots of polynomials, okay? And a lot of the problems that we've worked, we've found the real roots. We've talked about which roots would be complex or imaginary. And we know that when we have real roots or real zeros, what does that translate to on the graph? X-intercepts. Whenever we have a real root, that means that we have an x-intercept on our graph. Okay? So, number 1, find the roots or the zeros of x cubed plus x squared minus 4x minus 4. Now, this is not a new problem. This is a problem we know how to do. What method could we use to solve this problem? Yeah, this problem, factors. This polynomial, this cubic polynomial, factors. Okay? Now, when you're trying to decide what method to start with, always double check that you can't factor. Okay? Because factoring is definitely going to be the easiest thing to do. So, we have 4 terms, so what method do we use? Grouping. So, group my first 2. Group my last 2. What can I pull out of x cubed and x squared? So we've got x squared times x plus 1. What am I going to pull out of here? Negative 4 times x plus 1. So then I'm going to have an x squared minus 4 times x plus 1. Am I done? No, what can I do now? Not yet. Yeah, difference of squares. This turns into x plus 2, x minus 2. This turns into x plus 1. All right, so what are my roots? So negative 2, negative 1, and 2. Are those real roots? Yep, so they also represent x-intercepts. Good. Let's talk about what else we know if we want to try and graph this. What's my y-intercept? Negative 4. Good. If I plugged in x to all of these, I'm going to get negative 4 as my answer. What's going to happen to the right? Are we going to rise or are we going to fall to the right? Rise to the right. How do we know? Good. My leading coefficient in this case is 1, which is greater than 0. So I'm going to rise right. What am I going to do to the left? Good. How do we know? Good. So can we sketch a graph of this? Sure. So hopefully yours looks something like this. Plot our roots, we plot our y-intercept. Make our end behavior work. What's the domain of this function? Yeah, negative infinity to infinity. Okay. We don't. What's the range in this case? We do know. Look at your arrows. Yeah, negative infinity to infinity, because it's going to keep going up and up and up, and it's going to keep going down and down and down. Okay? Now, we're not always going to be able to tell exactly the domain and range, but you know the domain's always going to be what? Yeah. What about the range? When will the range get sticky? Good. When the degree is even, it's all either both sides are going to point up or both sides are going to point down. So you would have to know the highest point that it reaches. And we haven't talked about how to find that. That takes calculus. Okay? So let's try a new one. I want to know how many times is 2 a root of x to the 4th minus 5x cubed plus 6x plus 4x minus 8. So what does this question imply? That 2 is a root, and what else does it imply? Yeah, it might be a root more than once. So we have to figure out how often it's a root. Now, if I first just wanted to test if 2 was a root, what could I do? I could plug it in for x. What else could I do? Synthetic division. All right, so let's go ahead and set up synthetic division with my root of 2. Again, make sure that all of your places are accounted for. All right, you work it on your paper and then check on back up here, see how you did. Nope, because it's not asking you about the factor. It's going ahead and giving it you as a root. Okay? Good question, though. Oh, that's not good. Stories. All right. So is 2 a root? Yeah, how do we know? Yeah, this remainder is 0. So that means 2 is a root. But we said that this question implies that 2 may be a root more than once, right? So let's try this again. Now, we've already factored out, essentially, an x minus 2. So let's try it with what's left. We're only worried about now this new polynomial. Could I write this out and then start over synthetic division? Yeah. Wouldn't it be the same, though, if I just left these coefficients where they are? Yeah? So let's try that. I'm going to switch colors so we know we're doing this a second time. And now we're going to see if 2 is a root of what's left over. Is 2 a root this time? Yes, it is. Because how do I know? Yeah, my remainder is 0. So 2 is a root a second time. What should we do now? You sure? Okay. Let's try it again. Remember, this remainder essentially kind of falls off because we know it's gone. Does it work again? Yep, works again. So let's try it one last time, see if it works this time. Does it work this time? No. So, how many times is 2 a root of this quartic polynomial? 3 times. So 2 is a root 3 times. This is the same as saying it has a multiplicity equal to 3. 2 is a root 3 times, or you could say it has a multiplicity of 3. Could I write this quartic in factored form? If 2 is a root 3 times, shouldn't there be 3 of the same factors? And what would that factor be? X minus 2. Good. So I have x minus 2 3 times. X minus 2, x minus 2. And what is my last factor? No, because remember, this one didn't work. Yeah, it's just this right here. That was what was left over after we divided out. We used synthetic division 3 times, and we got 3 x plus 2 factors. Or sorry, x minus 2 factors. So this is my x, and this is my constant. This was my remainder. So yeah, my last term is x plus 1. What's another way you think of to write this? X minus 2 cubed times x plus 1. So this cubed matches the multiplicity. Okay? So I have a triple root, or a multiplicity of 3 root at 2, and then where's my other root? Negative 1. Where's my y-intercept? Negative 8. Good. You find the y-intercept by going up to your original polynomial and plugging in 0 for x. So when I plug in 0, everything with an x goes away, and it's always going to be what's left over as my constant. Okay? All right, so at negative 2, oh, sorry, not at negative 2, right? It's at positive 2. And negative 1. And I'm just going to put 8 here, if that's okay. All right, talk to me about our end behavior. What's going to happen to the right? Rise right. I have a coefficient of 1. And what's going to happen to the left? Rise. I have an even degree. All right? So at x plus 1, at my root of negative 1, I just have it one time. So just like normal, I'm just going to go through it. Just like that. Okay? But at x equals 2, I have a multiplicity of 3. So what happens is that at 2, it's going to take on the likeness of the parent function x cubed, and it's going to do a little curve. Okay? Do you see how it kind of looks like a little curve through that point? Like the parent function y equals x cubed, because it has a multiplicity of 3. So when you have a multiplicity, it tells you how it acts. It acts like the parent function. So this is a bend like the cubic function. And that always happens with a multiplicity of 3. What do you think would happen with a multiplicity of 2? What parent function do you think it would act like? The quadratic. So if it had a multiplicity of 2, instead of going through that root, what do you think it's going to do? No? If it acts like the parent function right here, it's going to look like a parabola. So it kind of hits it and bounces off. Yeah, kind of bounces off. So, for example, we're going to hopefully get to one later today. I don't want this to confuse you because this is a different problem. But if I had a multiplicity of 2, you might have a graph that was like, say my multiplicity of 2 is right here. I might have a graph that does this and then bounces back off right there. That's what I mean by bounces off. It like comes up and hits it and then bounces in the other direction so it looks like a parabola. Or it could look like that type of thing. Bounces off that direction. Mm-hmm. Yep, it kind of acts like a vertex. Good. Okay? All right. Keep going. So, this new stuff that we're starting right now, this is not on your quiz tomorrow, okay? This new stuff that we're starting is not on your quiz tomorrow. I'm sorry? Yeah, this is something new that we're starting, okay? So, if you'll remember, a lot of times yesterday and the day before, I guess Friday, when we found roots, I gave you a hint. I said, hey, try x plus 3 as a factor. Or see if 4 is a root. Okay, I gave you the hints. But you're not always going to have the hints. Sometimes you're going to have to come up with the roots on your own. And when you can't factor to come up with roots, you're going to use this thing called the rational root theorem. So take a moment to copy it down, and then I will do my best to explain it and show you how we're going to use it, which is really when it'll make more sense. So, P is going to represent factors of our constant. Remember, the constant is that term without any variable. Okay? And Q is going to represent factors of the leading coefficient. Now, I really don't care if you remember which one's P and which one's Q. Okay? I just remember that it's factors of the constant over factors of the leading coefficient. And every combination we can make of those factors over factors, those are possible rational roots. Possible rational roots. Okay? So is this going to help us find imaginary numbers as roots or imaginary roots? No. It's not going to help us find imaginary roots. It's also not going to help us find what are called irrational roots. Okay? Irrational roots are things like 3 plus or minus the square root of 2, or the square root of 3, or something like that, okay? Things that don't end in a decimal, you can't type in your calculator and turn it into a fraction. That's irrational, okay? This is only helping us find rational roots.
So if you tried this, it wouldn't work. Like, if you had a problem you didn't know if it's going to be real or imaginary roots, would you still try this?
Mm-hmm. Okay. All right. So we're going to use this theorem, and we're going to guess and check to find the ones that work. Okay. This can be a tedious process. So that's why we enjoy having synthetic division, to kind of make it move quicker. Okay. But some of these you're going to have to guess and check quite a bit. Okay. I will show you a tool to help you kind of narrow down your options. But you've got to be okay with testing something out and seeing that it doesn't work, crossing it off and moving on, trying something else. Okay? So, let's go ahead and look at our next example. I want to find the roots of f of x equals x to the 4th minus x cubed minus 5x squared plus 3x plus 6. So it's P over Q, factors of the constant, over factors of the leading coefficient. What is my constant? 6. It's this number that has no x's with it. What's my leading coefficient? 1. Let's list all the factors of 6. 3, 2, 1, and 6. The only thing I have to add is I have to add positive and negative, okay? Because those are also factors. So I'm going to have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And what are my possible factors of 1? Just plus or minus 1. So I'm going to do P over Q, constant over leading coefficient, and I'm going to go through and think about dividing all of these. So it's nice because since I have a 1 on the bottom, what list am I really just left with? Yeah, the factors of the constant. Because if I divide each of these by 1 or negative 1, I'm just going to get another 1 on that list. So P over Q in this case is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. How many possible rational roots are listed here? 8. Could they all be roots? No, why not? It's a quartic, so what does that mean is the maximum number of roots we could have? 3. Oh, wait, no. 4. Sorry, maximum number of turns is 3. Okay, maximum number of roots would be 4. Okay? In fact, I shouldn't really say maximum number of roots. I should say there are 4 roots. But do they all have to be real? No. So maximum number of 4 real roots is 4. But we could have 2 real, 2 imaginary, something like that. All right? So now we start guessing and checking. And always start with your easier numbers. So let's start with positive 1. Set up synthetic division using our quartic up here. 1, negative 5, 3, and 6. Work it on your paper and then look up here to check your work. Oh, whoops. What does this tell me? Yeah, 1 is not a root. My remainder is not 0, so 1's not a root. So we cross it off and we move on. What should we try next? Negative 1. No, but once we get it down to something we can factor, then we can stop. Okay? But we've got to use this to figure out like our starting point. All right, so is negative 1 a root? Yeah. Our remainder is 0, so negative 1 is a root. So this would be my constant, this would be my x, this would be my x squared, and this would be my x cubed. Can you look at this for a minute and think about, would this be able to factor? Yeah, I have 4 terms, so I could use grouping. And would grouping work in this case? Yeah. So whenever you're able to stop and factor, your life becomes a lot easier. So let's write this down and let's factor this. X cubed minus 2x squared minus 3x plus 6. I would pull out an x squared. I would have x minus 2. Pull out a negative 3. I would have x minus 2. So this factors to x squared minus 3 and x minus 2. So I know negative 1 is a root of mine. What else do I now know is a root of mine? Okay, I now know, yep, that 2 is a root. I'm going to circle that. Okay, so that's 2 of my roots. Do I know the other 2? Yeah, could I solve this one? Think x squared minus 3 equals 0. X squared equals 3. What's x going to be equal to? Plus or minus, good. Oh wait, square root of 3. Well, do you notice that plus or minus the square root of 3 was not an option up here? So I just can't use this to develop my irrational roots. But I can work with my rational roots to get to something to figure out my irrational roots. So my roots altogether would be negative 1, 2, and plus or minus the square root of 3. What kind of roots are these? Real. These are 4 real roots. All right, Haley.
Can you write the square root of 3 like twice, like the square root of 3 and then minus 3?
Sure, that's fine. Other questions? Okay. I want to find the roots of 2x cubed minus 5x squared minus 14x plus 8. So would you see if you can come up with the list of possible rational factors? Okay? So I want you to think, of roots, possible rational roots. Okay? I want you to think about what your constant is, what your leading coefficient is. Write out your lists and think about what your list of possible roots are. So P stands for my possible factors of what?
Constant.
The constant. So what are the possible factors of 8?
Plus or minus 2, plus or minus 4, plus or minus 1, and plus or minus 8.
Over Q, which are the possible factors of the leading coefficient, which is 2.
Plus or minus 1, plus or minus 2.
Good. Okay, now you think of going through and dividing all these, right? So if I divide everything on top by 1, I get left with just that list again, right? So go ahead and write that list out. Okay, now think about what happens if I divide everything by 2. What's the only new possible root that's going to appear? Yeah. Because if I divide 2 by 2, 4 by 2, or 8 by 2, those numbers are already on there, right? The only one that's not on there is if I divide 1 by 2. It's plus or minus 1.
What about, would you get rid
Oh, sorry, 1/2. I'm sorry?
would you get rid of plus or minus 8?
Nope, because 8 over 1 is still plus or minus 8. So you go through this list and divide by the first number, go through this list, divide by the second number, go through this list and divide by the third. Mm-hmm. So here are my list of possible roots. Okay? Now, some of these can take a long time to guess and check with. Right? So I'm going to show you a little bit of a shortcut that might help you narrow down the options. Right? If you don't have your calculator out, that's okay. You can just watch me up here. Okay, I've got the calculator pulled up here. In y equals, I would like for you to type in the original polynomial that we started with. The original polynomial that we started with. All right, do I have it? All right. Now zoom 6. And go ahead and look at your graph. Okay? What points on here should help me decide what to try? Yeah, where it crosses the x-axis. Okay? Okay? So, do you see on the graph one of our possible factors that we should maybe try? -2. So let's go back to our problem and let's try -2. Huh? Mm-hmm. Now, just because I'm letting you use your calculator to help you get an idea, okay, that's for a time-saving purpose. It's not so that you don't have to know how to do synthetic division, okay? I don't want you to sit on your calculator and calculate the root. If you think -2 is a root, I need to see you do synthetic division with -2, okay? So is -2 a root? Yeah. -2 is, in fact, a root. Okay? Once you get it down to a quadratic, and what I mean by that is after you do synthetic division, if you have a constant, an x, and an x squared, then immediately at that point I would stop and either try and factor or try and use the quadratic formula. There's no point to continuing synthetic division and testing things that might not work when you know 2 surefire ways to solve quadratics. Okay? So let's go ahead and write out this quadratic that I have now. We've got 2x squared minus 9x plus 4. Will this factor? Yep. 2 times 4 is 8. Are there factors of 8 that add up to -9? Yep, -1 and -8. So take a second and factor this. The reason I'm having you practice this factoring, guys, it's not going away. You've got to know how to factor this. The quicker you know how to factor and the better you are at factoring, the easier you're going to work your way through these problems. What did you get? Good. 2x minus 1 and x minus 4. So what are my other two roots? 1/2 and 4. All right? What if 2x squared minus 9x plus 4 did not factor? Yeah, quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? We'll practice one of those if we have time at the end. Questions? Do you understand what I say when I mean that your graph is a tool? It is not for you to solve with. I don't want to just see negative 2, 1/2, and 4 on your paper. That doesn't tell me you understand the process. But I don't think... Excuse me. I also don't want you to sit on your homework and run through a billion different options and waste a lot of time and get frustrated and then not finish your homework, okay? So if you have one to test, you're going to do synthetic division, then you're going to either factor or show me the quadratic formula. Might you have to do synthetic division twice? Yeah, what if we had a quartic up there? If we had a quartic, you would have to do synthetic division twice in order to get down to the quadratic. Okay? That one? Yeah. What I did was I plugged it into my y equals. And I looked at my graph and I got an idea. Plugged it into my y equals and I looked at my graph. And I know that my roots are where it crosses the x-axis. So I could have tried, I guessed with negative 2, but I could have also guessed with about a half, or 1, 2, 3, about a 4. Okay? Now notice, this looks like it goes through a half, right? But if you had tried a half and it didn't work, what would that mean? Yeah, it wasn't exactly a half, right? It could have been going through it 5/8 or 3/8 or something like that. So just know that sometimes it might not always work. And then you would just try maybe one of the other ones. Okay? All right, let's try another one. X cubed plus 4x squared minus 11x plus 6. So, if we don't have any hints, what do we start listing out? Possible factors. So we're going to think about P over Q. So you can come up with your list of possible factors. Factors of the constant over factors of the coefficient. When you have plus or minus 1 on the bottom, it just turns into your factors of your constant. All right, and what's the easiest one we start with? What? Give it a try on your paper. Look up here if you get stuck, or to check your work. What does this tell us? 1's a root, because my remainder is 0. Am I at a quadratic now? Yeah. If I weren't at a quadratic, and what I mean by that is the cx and x squared. If I weren't here, I would keep trying possible roots using synthetic division until I get to a quadratic. Okay? So once we're at a quadratic, we're going to stop and we're going to use factoring or the quadratic formula. I know none of ours in our notes have had the quadratic formula. They've all factored. But I mean, I'm telling you, some of your homework questions do need the quadratic formula. Okay? They're not all going to factor. What does this factor to, though? Okay. So what are two other roots? 1, -6. All right, so what do you notice about 1? Yeah, it shows up twice. So what did we learn earlier today that we could call that? Multiplicity of 2. So our roots are 1. You could list 1, 1, -6. Or you could say 1 with a multiplicity of 2 and 6. What does this look like in factored form? Leah? Yes, that would be good. How would I write this cubic in factored form? Yeah. You could also write x minus 1 times x minus 1 times x plus 6. That's definitely acceptable. That is still factored form. All right, so let's graph this. I have a double root at 1. I have a single root at -6. What is my y-intercept? 6. End behavior to the left. Or sorry, let's start with the right. End behavior to the right. Rise. End behavior to the left. Fall. So this is a single root at -6. So I just go straight through it like I'm used to. Go up to my y-intercept. When I get down to my root of 1, that has a multiplicity of 2. So it's going to bounce off like a parabola. It hits at the x-axis and then it bounces off.
The number of terms is the degree minus 1, right?
Right. Yes, Leah.
So instead of like going down and then up to 1, it would just it would hit 1 and go off.
Uh-huh.
What does it mean by multiplicity of 2?
That means, think about it like if you were to write it in factored form. How many times does my factor of x minus 1 show up?
Okay.
Shows up twice, so it has a multiplicity of 2.
So, but on the graph, it doesn't really make a difference if you were to graph it?
Yeah, so a multiplicity of 1, like at -6, we just had that root once. We go straight through the x-axis. Okay?
Oh,
If a multiplicity of 2, we're going to hit that root and come back up. And back to that very first one we graphed. If it has a multiplicity of 3, it's going to bend through that root, like a cubic function. Okay?
There's no special, like, way you mark it. So
Nope, just by showing it on your graph like this. Okay? All right, I want to practice one quadratic formula just to dust it off in your brain. Okay? So let's practice x squared plus 3x plus 5 equals 0. Does that factor? Are there any factors of 5 that add up to 3? Nope. So let's practice the quadratic formula just real quick. Negative b, what would that be? Negative 3 plus or minus the square root of b squared is 9 minus 4 times 1 times 5 all over what? 2. So this is negative 3 plus or minus the square root of. So we get 9 minus 20. What's 9 minus 20? Negative 11 over 2. What's the only way I can simplify this further? Yeah, negative 3 plus or minus the square root of 11 I over 2. Just a little refresher, okay? You're not all going to factor on your homework, okay? So you got to remember quadratic formula. All right, there have been some changes to your homework. So please get your homework from this up here, not from your timeline. We took out a couple problems, okay? So your new homework is on page 443, numbers 16, 29 through 31, 33, 37, 42, 43, 45. This is different than is on your timeline.